Hey there, Algebra 2. Welcome back to another episode from Chapter 5. We've got Section 5.5, Theorems about Roots of Polynomial Equations. And our goal today is to use the conjugate root theorem. So here is the conjugate root theorem. If P is a polynomial in one variable with real coefficients, and A plus BI is a root of P with A and B real numbers, then its complex conjugate A minus BI is also a root of P. So what we have here is, if we've got a complex root A plus BI, that means that within this polynomial, you're also going to have the conjugate root A minus BI. So it's kind of like a 2-for-1 deal. If you know that one of your roots, say, is 3 plus 4i, that's one of your solutions to your polynomial, then 3 minus 4i also has to be one of your solutions or one of your roots. Remember, solutions, roots, they're the exact same thing. They mean the same thing. So if you have that root 3 plus 4i, that also tells you then you have a second root 3 minus 4i. And just a reminder, the quadratic formula, we've now started to work the quadratic formula back in sections 1, 2, 3, looking at finding imaginary complex solutions quite a bit. When you have your quadratic formula, you have this plus minus in it. So when you use the quadratic formula to find those complex roots, you're always getting those complex conjugates, 3 plus 4i, 3 minus 4i, etc., etc. So we're going to take a look then at problem 1. Problem 1 says a cubic polynomial P has rational coefficients, which we talked about above, so it's fitting the conjugate root theorem. If 2 plus 3i and 2/3 are roots, what is one additional root? Now the key to focus in on here is actually a couple of things. A cubic means that it is going to have 3 roots. So I have to have a total of 3 roots, whether they are real or imaginary. Then I look at the roots I'm given. I'm given this complex root, 2 plus 3i. 2/3, that is a real root. So the real root would be 2/3. The imaginary is that 2 plus 3i. Now here's where I can use the conjugate root theorem. If 2 plus 3i is the root, my one additional root is going to be 2 minus 3i. So I'm still using the exact same a and b. I'm just now using 2 minus 3i. So remember, if you have a polynomial with real rational coefficients, then your imaginary roots will come in conjugate pairs. So we got a 2 plus 3i, and 2 minus 3i is going to be my answer that I'm looking for. That's my additional root. And keeping track, that's going to be my one root. There's another root, and then there's my third root. So I've got all 3 roots for that cubic polynomial. Problem 2, we are going to write polynomials from their roots. So we're going to find a quadratic equation. So just keep in mind, a quadratic equation is going to have 2 roots with the root of 1 plus 2i. Now you're looking at this with a root. This is only one of those roots, so I have to use my conjugate root theorem. Another root then is going to be 1 minus 2i. There's my 2 roots. Now I have to write a quadratic equation from those 2 roots. This is something we started to practice in section 5.2, where we were writing polynomials from roots. Now we're going to practice how can you write a quadratic or any polynomial from imaginary roots. So this is going to take some unique algebra that is all skills that you know, but is just unique to this situation. So we'll start out by writing our root. X is equal to 1 plus 2i, 1 plus or minus 2i. So that is the only thing I know so far, is that my x is equal to 1 plus or minus 2i. Now here's the algebra that we're going to use. We're going to isolate the I, because right now we have an imaginary, and we have to write a quadratic equation that's got all real coefficients. So we're going to get the imaginary part isolated. So we got x minus 1 now is equal to plus or minus 2y. Now something we talked about in chapter 8. There is a way that we can change imaginaries back to real numbers, is we can square them. So what I'm going to do next is I'm going to use that little trick to get I changed back to a real number. So I'm going to square this side. Now if you square one side, you have to square the other side. So we're going to square both sides. And here's what it would look like next. So on my left side, when I square that binomial, I'm going to have x minus 1 times x minus 1, because I have that base of x minus 1 multiplied twice. When I square the right side, I'm going to get 2i times 2i, because I'm taking that base of 2i, multiplying it twice. It doesn't matter if we use positive 2i or negative 2i, because when you square, you're still going to get the same result no matter what. Now on the left side, I'm going to have to use FOIL. On the right side, I'm going to do 2 times 2, which is 4, and then I times I, which is I squared. So on the left side, I FOILed out x minus 1 times x minus 1. I'm going to get x squared minus 2x plus 1. And on the right side, I have 2i times 2i, which is 4i squared. So you can see on the left side, I'm starting to form that polynomial. So let's continue. Now I'm just going to rewrite this up here, but I'm going to start to now adjust this I squared. And here's where the magic happens. I've now got 4i squared, which 4 I squared really would be 4 times negative 1. I'm going to substitute negative 1 in for that I squared because they are equivalent to each other. So now we've got x squared minus 2x plus 1 equals negative 4. And the only thing left to do is to add that 4 back over because we want our polynomial set equal to 0. And we're left with x squared minus 2x plus 5 is equal to 0. So there would be my polynomial that's got the two complex roots of 1 plus 2i and 1 minus 2i. So we're going to use that same algebra again, so we'll get another practice with that last problem in problem 3. So problem 3, we're going to read through and just kind of point out some important things to keep track of. A quartic. A quartic is going to mean that we're going to have 4 total roots. Quartic polynomial with rational coefficients so that p of x equals 0 has roots of 1, 3, and 1 plus 2i. So I've got a root of 1, I've got a root of 3, and now I need a root of 1 plus 2i. Now if I look at that, I got 1 root, 2 root, 3 root. Well, a quartic, I need to have 4 roots. Where is that other root? The conjugate root theorem. 1 plus or minus 2i. Because if I have a complex root 1 plus 2i, that also means I have that complex root 1 minus 2i. So there is my 4 roots. I've got 1 right here, 1 right here, and then I've got 3 and 4 right there. There's all 4 of my roots. Now let's start building this polynomial. So we'll rewrite the root of 1 as a linear factor. Just subtract that 1 over, or you can think of it as a x minus a form. We're going to do x minus 1. X equals 3. That's going to be the root x minus 3. So there's my real part of my polynomial. Now we get to work over here. A little bit extra to get these imaginary complex roots. So I got x minus 1 equals plus or minus 2i. We'll square both sides. And there we go. Now we're left with x minus 1 times x minus 1 equals 2i times 2i. Then we'll FOIL it out. We got x squared minus x, which is minus 2x. Negative 1 times negative 1 is positive 1. There's our FOIL. And that's going to equal 2 times 2 is 4. I times I is I squared. That's going to equal negative 4. And lastly, we'll get x squared minus 2x plus 5, equals 0. So there's going to be my imaginary part. Now I've got two parts here. I've got the real part, which will FOIL out to x squared minus 4x plus 3. And then I've got this imaginary part over here. I do need to make a quartic polynomial, so now I'm going to need to take and multiply this trinomial x squared minus 4x plus 3 by x squared minus 2x plus 5 to get my quartic polynomial. So that's what we're going to do next. So here's how we can multiply a trinomial times a trinomial. We're going to have a triple distribution. So I'm going to need to take x squared, multiply it out once, twice, 3 times. So x squared multiplies all 3 terms in that second polynomial. Next, we'll take negative 4x, multiply it out once, twice, 3 times to each term in that second polynomial. And lastly, we'll take the 3 and we'll distribute it once, twice, 3 times to that second trinomial. From here, now we're going to start combining terms. So I've got an x to the fourth. That's the only x to the fourth that I have. Next, I've got a negative 2x to the third and a negative 4x to the third. So that's going to combine to make negative 6x to the third. Then I'll have 3 squared terms. So I got a positive 3, a positive 8, which is positive 11, and a positive 3, which is positive 14. So I got a 14x squared. And next, I can count my linear terms. I've got a negative 20 and a negative 6, which is negative 26x. And lastly, a 15. So there would be my quartic function with zeros, real zeros of 1 and 3, real roots of 1 and 3, and then complex roots of 1 plus or minus 2i. One thing you can then do to check is you can put this into your calculator and just make sure that you can find those real roots. Now, one thing I did do when I checked it was I noticed that when I distributed the x squared, that this, I had written down a 3x squared. It should have been a 5x squared. So I just miswrote that. But when I checked it in my calculator, I could tell that the zeros weren't lining up, so that I did a little mistake, and then I went back and checked my work. So if you're taking notes, you can pause right here. You should change this to a 5x squared, and then that's going to make this 16x squared. Now you can go put that into your y equals, and if you hit graph, you should see your function will come. It'll hit at 1, and then it'll also hit at 3. So there's your 2 real roots, and then this would also have the roots of 1 plus or minus 2i. So we can see those right there. So sorry about that little mistake, but that would have been a 5x squared when I was doing that triple distribution, and then that would end up being a 16x squared in my final answer. Well, that concludes lesson 5.5, starting to get into some interesting algebra, but using the roots and what we know about roots to write polynomials. And then you always use that calculator. You can go back and check those answers. You are now ready to take a look at 5.5, and we'll see you next time.